let's see if we can warm up with an easy flux integral. So this is number 30 out of 19.2. I want to calculate the flux of the vector field F is zk through the surface S, where S is part of the plane x plus y plus z is 1 in the first octant, and then I probably want to know an orientation, right? So I'm going to orient this thing upwards. Cool. So maybe just to start off, I should ask, is this a candidate for one of the three big theorems? Let's see. So what are the three big theorems? I've got Green's, Stokes, and the divergence theorem. So is this a good candidate for Green's?
No.
Why not?
It's not flat.
Yeah, perfect. Green's only works in two-dimensional stuff, right? It's a thing about flat.
That's not even a
Yeah, this isn't a circulation integral anyway, right? So, okay, it's probably not good for Green's. It's also not an area integral, right, which would be the other side of Green's. So I can't even use Green's backwards.
We can't do divergence, but it's not a closed surface, right?
Perfect. This thing's just a chunk of a plane, right? It looks like this, maybe, roughly. Yeah, it's not a shell, right? I need a closed surface for the divergence theorem, and I can turn that into a volume integral, right?
You could do Stokes, right?
Yeah, we could try Stokes. So Stokes says I could trade this surface integral for an integral around the boundary, right? I think, something like that.
Dot the curl with the dA, right?
Okay, but even if I tried that, right? What would I would trade my one integral around the surface for what?
Area. Right.
Three line integrals, right? Curl trades, line integrals, and surface integrals. So I could maybe think about if I turn this using Stokes into line integrals, I'm going to need three of them. Because I'm going to need this one, and that one.
So
right?
we have to parameterize three curves.
Yeah, so I'd have to parameterize three curves. That sounds like a pain in the ass. The other thing about using Stokes on this one is that Stokes has the curl in this part and the regular vector field in the line integral. So I'd have to try to figure out what this vector field is the curl of. That might be a pain in the ass. That's like backing out of a derivative, right? Kind of. That might be really hard. So let me not use a big theorem and just do this the old-fashioned way. So how do I do this the old-fashioned way?
It's a function.
Okay.
Just like we did with that formula.
Perfect. So I could rearrange this into a function, or I could forget it. Let's rearrange it into a function. So this thing means that z is what?
1 minus x minus y.
1 minus x minus y. Okay. So then what?
Vector negative fx negative fy 1.
Okay, so I need to think, okay, the area for functions is negative fx, negative fy, and 1. The irregular area. Okay, so what's fx and fy for that thing?
We don't need those. Because we just have zk.
Oh, good call. You guys see that? Whatever they're going to be, right? I'm going to make my surface integral. I'm going to take my integral over the surface. I'm going to do zk, right? And I'm going to dot with this stuff. So I've got minus fx, minus fy, and 1, the area. And when I do this dot product, what am I going to get? I'm going to get the integral over the surface of z So, yeah, the dot product of k with I is 0, the dot product of k with j is 0, and the dot product of k with k is 1. So I just get z out of that. Let's pull that. Okay, so I got z the area. That's weird.
So we could either do a triple, or no, yeah, we could have.
I'm doing ds dy, and we gotta change z to x.
Perfect. I know what z is. Z is 1 minus x minus y.
Why is the
So
dot?
0 to 1 minus.
What's the dot product then?
K as a
If I wrote zk as a vector, right, it'd be 0, 0, z.
Oh, okay.
And then with my dot product, it's pretty clear we can see. Okay, so I've got a double integral of, okay, I know what z is. It's 1 minus x minus y. And then I need a d x dy. And now I need to figure out where the x's and the y's go, right?
Yeah.
Okay.
The x equal 0 to 1 minus y.
Nice. Something like that. How do you figure that out?
I found what values y would equal x.
Oh,
With
you
the
said this
prearranged.
equal to 0, right?
Yeah,
Okay, so maybe I need a,
a little more.
no, I mean, that's fine, but it happens that this cross-section is kind of what it is, so you got a little lucky. So let me draw a picture of this thing. So here's my usual x, y, z, right? What's that thing look like if I set y as 0?
1 minus x.
Y and 1 minus x. So I go 1 in the z, and then I'm going down 1 over 1, right? So I've got, there's my line, 1 minus x in the xz plane, right?
Yeah.
What if we set x as 0?
You're gonna get 1 minus y.
1 minus y. So you get another chunk of a very similar line, right? And then it's plane, right? So what am I going to do with those two dots? Connect them, right? Because it's a plane, it contains all the lines in between its points. Okay, so there's my chunk of my plane in the first octant, and I want to know where the x's and y's go in that thing, right? So if I thought about smushing the z's out of this, right? I've got this picture. And this line here is identically what you get when you set z as 0, right? So that's the line y is 1 minus x. Or x is 1 minus 1. Whatever. So if I integrate the x's out first, the x's range from, oops, x's range from
0 to 1 plus 1.
x's range from 0 to 1 minus y. And then the y's, they range from 0 to 1. Perfect. Cool. And then if we do this, should we finish this off to get a number? It'll only take a second. Okay, so I get the integral from 0 to 1 of what?
X minus x squared minus x y.
X minus x squared
Over 2.
minus xy, and maybe over 2 in the middle. And I'm evaluating from 0 to 1 minus y, and then I'm going to integrate dy. So I've got the integral from 0 to 1 of 1 minus y minus
1 minus y squared.
1 minus y squared over 2 minus
1. Y minus y squared. Y times. Y minus. Or plus, yeah.
well, distributing will get you to minus y plus y squared. Then we're going to do dy to that. So I guess I have a what? foil on my hands? Okay, so it's foil. What do you get out of the foil bit?
1 minus 2y plus y squared.
Oh, right. 1 minus 2y plus y squared.
And then that little thing that we have to solve.
And then I need a minus on the whole thing. And I need an over 2. Okay, and then I need to combine like terms. So I got the integral from 0 to 1 of what?
1/2
1/2.
minus 1/2 y squared.
No, you get 0, because isn't that 2y? Minus, plus 2y?
So I did this whole piece.
Divided it by 2.
Oh, you
That's
divide
all
by
that.
2. Oh, okay.
I flipped the signs and I divided everything by
Okay.
2, so that's
Then-
that whole piece.
Alright, then it's just minus y.
So I've got a minus y, a minus y, and a plus y. So I got a minus y. And how many y squareds you got?
You're gonna get a minus y squared over 2.
A positive y squared over 2. Then I'm supposed to be integrating dy. Okay. Now what? Yeah, it was really calc 2. Well, I guess this wasn't calc 2. Okay, calc 2 it. So you get 1/2 y minus y squared over 2 plus y cubed over 6. Evaluated from 0 to 1 gives you 1/2 minus 1/2
No,
plus
it's-
6.
So I'm guessing.
Seems like a sixth is the answer. What does the sixth tell you?
I don't know about that, but why is it y squared over 2 right there?
Oh, this guy?
Yeah, where are you getting that from?
I got a y squared and a minus y squared halves.
Yeah.
So if you have something and somebody takes half of it away, you have half of something left.
Okay.
He foiled that little
It
part
just
down
seems like
there.
hand waving, but okay.
I've got 1 y squared here,
Yeah, no, I got it.
and then in that bit I've
2
got
over 2.
minus 1/2 of 1. So still skeptical.
If you're wondering where the minus sign came from, it came from ahead of
That came
foil.
from this.
No, I understand where minuses come from, and I got that part. Just talking about why it was positive on the bottom. That's it, thanks.
Okay.
It's your first mistake.
Complimented her hair. Alright, so I get a sixth. What does the sixth mean?
How much makes it through the vector?
1/6 units flow through.
Yeah, perfect. This has a sixth flow through this thing, right? The flux through this is 1/6. Which means, right, that there's a net positive flow through this thing. And this thing being this little plane, right, this chunk of a plane, and the vector field being the one that points up, that kind of jives, right? Did I orient this thing the way they told me to?
Yes. No. Because the
Orient
vector
it
field is pointing
upwards.
They said I should orient the triangle upwards, right?
Yeah.
How do I know I oriented it upwards?
That formula.
Yeah, the dA formula that I erased that we used, that comes with upwards pointing. If I wanted downwards pointing, what would I do? Get to the end, flip the sign. Cool, question, thanks?